Hello, this is a geometry video. It is chapter 3, section 6. It is the last section in this chapter, and it is perpendiculars and distance. So the first thing I want to talk about is the distance between a point and a line, which seems kind of basic, but there are a couple of things that we have to make sure that we know. For example, if someone asks you what the distance between point C and the line AB is, I'm sure that we could come up with several different options. It kind of depends on how you draw it. If I, for example, wanted to draw the line like that, I could measure that distance and it would, tell me who knows what. I could also draw the distance from C to B like that. And I'm pretty confident that you can tell that both of these distances are different. The distance from C to B is a lot longer than the distance from A to C. And we could draw different segments all along here, and each time we would get a different distance. Well, that's not good. We want to have something that is always consistent. So for our purposes, the distance between a point and a line is always going to be the shortest distance, and that distance will be the distance that is perpendicular from the point C to the line, which neither of these that I've drawn so far will give us. So I'm going to go ahead and draw in what would be the accurate answer, and it would be a distance that we would draw that is perpendicular to the line AB. So just as a point of concept or a point of definition, that is how we determine the distance between a point and a line. And so that brings us to the perpendicular postulate, and it's over here on the right. It says, if given a line like line M and a point that is not on the line like point P, then there does exist exactly one line through the point P that is perpendicular to the given line. So it's not a really hard thing to think about. Of course, postulates are always things that are kind of common sense. They don't require a theorem because they're pretty straightforward. So that's the perpendicular postulate. And so here we have an example. Now in your book, there's a nice little pretty picture, landscaped and the whole shebang bang. I didn't do that, but it's all right. And what I am going to do is use my trusty little handy dandy here. Let's see what is going on here. No, there we go. I need to put my pen in here somehow. So sorry for this delay. Okay, so it says a landscape architect notices that one part of a yard does not drain well. She wants to tap into an existing underground drain represented by line M. So right here we're going to have line M, and that's going to represent our drain pipe. And it says construct and name the segment with the length that represents the shortest amount of pipe she will need to lay to connect this drain to point A. So basically what we're looking for is that perpendicular distance, and this time I can't just ballpark it like I did in the previous example and just kind of say, oh, it's roughly right here. We have to construct it, which means we have to use our compass to be able to do that. But believe it or not, it's not that hard. I'm going to go ahead and bring out my compass, and to find perpendicular distance, it's actually pretty simple. You're going to put the needle point of your compass on point A, like so. And hopefully it's long enough to intersect 2 times. And let's do that in a different color. So there's point A, and I'm just going to draw an arc like that. And then I'm going to label the 2 points where it intersected the line, B and C. All right, now you don't have to name them B and C, but you can name them something. Now what I need to find is I basically know that B and C are the same distance from A because it's part of the circle, right, part of the arc. Now what I want to do is find the middle between B and C. And again, we've done that before as well, and that's actually pretty simple to do if you don't remember as well. All you have to do is make sure that your compass is open to more than half. I mean, we know that the middle is somewhere here, so you want to make sure that it's open to more than half. And then you're going to draw yourself two new arcs, starting from point B over here. You'll draw yourself an arc this way, and then with the same compass setting, you'll go to the other side and to point C and draw another one, like that. And then I don't need this compass anymore. And so now we know that the middle is going to be the point that is going to be here where these two meet, there and there. We're going to line up our straight edge or a ruler, and this is the middle right here. That point is the middle between B and C. So all we have to do is connect point A to that middle, and this, and we'll call this D. We'll call the middle point there D. And so now my segment AD is going to be the shortest distance from point A to the drain pipe. So it said in the example to construct, which we did, and name the segment. So the segment is going to be AD. And that will represent the shortest amount of pipe that she will need to lay to connect the drain to point A. All right, so now you are going to do this little example. You want to copy this triangle onto your paper. It doesn't have to be exactly the same as mine, but it should have a general form to it. And then you're going to construct and name the segment that represents the distance from Q. So here's Q to PR. So you're trying to go from here to here. And again, you have to draw your arcs and figure out what that is. All right, so now we're going to go to example 2. And example 2, it asks us to, it says line L contains points at -5, 3, and 4, -6. So that's line L. And it wants us to find the distance between this line and a point P, which is 2, 4. Now, I think that at first sight, you might think this is like, oh, really simple, just find the distance between the 2 points. That is not what's going on. So let me just kind of draw this out for you. Now, it doesn't ask you to graph anything, but I do think that at least for this first example, it might be helpful if I kind of draw out what exactly the scenario is, so you can see why all the steps that are being taken are being taken. It is quite a doozy of a problem. So we're going to go 1, 2, 3, 4, 5. We're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6. Okay, so it says line L contains points at -5, 3. So -5 is over here and 3 is up here, 1, 2, 3. So -5, 3 is roughly there. And 4, -6 is 1, 2, 3, 4. And this is -5, so this will be a little bit further down. And let's see if I can make these little guys connect. Excuse me, sorry that I'm a little bit under the weather here. So there's my line. This is line L. Line L contains -5, 3. So we have our point right there, -5, 3. And also 1, 2, 3, 4, -6, roughly right about there. And then it tells us they want us to find the distance between line L, so between this line, and point P, which is not on the line. So point P is 2, 4. So there's 2, 1, 2, 3. So here's point P, all hanging out over here. And they want us to find the distance between the line L and point P. So you see, you can't just take this point and P and find the distance. Okay, that's not what they're asking for. You can't do that with this point either. Why? Because those points are not the perpendicular distance. You have to find the point that is perpendicular to the line, and that will be the accurate distance to find. So then how do we do that? Well, the first thing we have to do is to calculate the equation of line L. So that's going to be the first thing on our list to do. So to do that, we're going to use the slope formula. We're going to label over here x1, y1, x2, y2. And our slope is going to be -6 minus 3 over 4 minus -5, which really means -9 over 4 plus 5, which is +9. So you get a slope of -1. Then you want to write the equation in y equals mx plus b, so you can use y equals mx plus b, or you can use the point slope formula. I'm going to use the point slope formula, so I'm going to go y minus y1 equals m times x minus x1. Excuse me. Now remember, I put a plus here because it's minus a negative, so that x1 was -5. So then to simplify that, y minus 3 equals -x minus 5. I add this 3 to the other side, and my equation is now y equals -x minus 2. This is the equation of line L. All right, now what we have to do is find the equation of the line that will be more or less this line there. Okay, I'm going to go ahead and call this line W just to give it a name, but we're actually trying to find the distance between point P and this point right here, but we don't know what that point is. So what we're going to do is we're going to find the equation of this line, and then we're going to solve the system to see where they intersect, and then that point and this point we're just going to use the distance formula. So I need to find the equation of line W. So the good thing about line W is that we know that it has to be perpendicular. So the line W will have a slope that is perpendicular to this line, and this line has a slope of -1. That means that this line has to have a slope of +1. Okay, so now we know what the slope is, and we also have a point. We know that point P is on this line, and the coordinates of point P are right here, 2, 4. So I can call that x1, y1, and I can do the formula again. Y minus y1 equals m times x minus x2, which basically just means that I get x minus 2, I add 4, so y equals x plus 2 is the equation of line W. So this equation right here is y equals x plus 2. Now you'll notice that when I drew the graph, I wasn't really interested in making the graph look perfect. They never asked us to graph anything. I just wanted you to see what was going on. And you can see that this is supposed to be y equals x plus 2, which means the y-intercept should be 2. And it's a little off. And the other line was -2, and that's a little off. So when that happens, everything can get kind of funky. So you don't want to just graph it and then kind of guess where it is. Okay, you want to make sure that the algebra makes sense. So even though this is not perfect, I know that the math over here is correct. So those are my 2 equations, and now what I want to do is find out where they intersect. And that's an Algebra 1 thing that we did last year, solving a system. You can solve a system with substitution, elimination. I'm going to go ahead and use substitution. And what substitution means is that you replace one of the equations with one of the variables. In other words, y equals x plus 2 here in this equation, and I have a y over here in this equation. So I'm going to replace the y in this equation with what the y is from this equation. So I'm substituting. So that means that I'm going to get x plus 2, because this y should equal that y. They should have the same value for y. So x plus 2 should equal -x minus 2. And then I'm going to solve for x. So if I add x to both sides and then subtract 2, I'm going to get 2x and negative 4. Divide by 2, and then I get that x equals negative 2. Excuse me. So the x-coordinate is negative 2, and now all I have to do is find the y-coordinate. To find the y-coordinate, I can plug negative 2 into either one of these equations, and it's going to give me the same answer, because that's the whole point. They're going to be the same. So if I plug negative 2 into this equation, negative 2 plus 2 is 0. So that means that the point of intersection here is actually x is negative 2, y is 0. Even though it doesn't, it looks like it's kind of off, that's what it's supposed to be, negative 2, 0. If I plug negative 2 over here, I'm going to get negative, and then negative is positive 2, minus 2, again, is going to be 0. So that's my point of intersection. The point P was 2, 4. Now that I have the 2 points, now it's a simple, straightforward distance formula problem. So now I'm going to use the distance formula to get the actual final answer. So you will remember that the distance formula tells us to take the square of the difference of the x's. So I'm going to go 2 minus negative 2, quantity squared. So I'm going to subtract the two x values from each other, 2 minus negative 2, and then square that. And I'm going to add the difference of the y values. So 4 minus 0, quantity squared. And so this minus negative is going to be a 2 plus 2. And of course, 4 minus 0 is just 4. 2 plus 2 is also 4. And 4 squared is 16, plus another 16. And so I get the square root of 32 is my exact answer. And then if we want to get the approximate answer, we can take our calculator, and the square root of 32 is approximately 5.65, 5.66, or maybe even 5.7, depending on how much you want to round. The exact answer being square root of 32, approximate answer 5.66 units. And that is how you find the distance between L and the point P. So now you can try this one on your own, and then we'll go to our last example. And I apologize that I am under the weather here, but please bear with me. So here we have a theorem. Basically, another way of looking at parallel lines is that two parallel lines should have the same distance between them. The perpendicular distance, of course, between them should always be the same. That's just another way of thinking of parallel lines. And so from that, we have our theorem 3.9. And it's important that you know the name of the theorem, because on a test or a quiz, if you had to put the reason down, theorem 3.9 wouldn't suffice. You have to actually have the name of the theorem. So the name of the theorem is two lines equidistant from a third. And it states that in a plane, if two lines, and in this case, those would be the red lines, if two lines are each equidistant or same distance from a third line, so the third line would be the black line, so the red line is equidistant from the black line, and this red line is equidistant from the black line. Then if that happens, the two lines are parallel to each other, so the two red lines are parallel to each other. And this just represents that the distance between these two is d, and the distance between these two is d, the same distance. So based on that, we have an example that's asking us to find the distance between the parallel lines L and M. And they're telling me what the equation of those lines are. Now again, they're not asking us to graph anything, but you should know that in a nutshell, I'm not going to graph the exact lines because it's not necessary, but I do want to kind of show you what they're asking us for. We have a line, and then we have another line that is parallel to it. They both have the same slope, so they're parallel, okay? So here's like our line L and our line M. And they want us to find the distance that's between the two lines. They want us to find this guy right here. So how do we do that? It's kind of crazy, right? So anywho, And it's a little bit of a process, but basically what we need to do is find the equation of a line that is perpendicular to one of these lines and then solve a system. So I think what I will do is, because I think it'll be easier for you to see, I'm going to go ahead and actually draw out the two lines. It shouldn't take too long. They're pretty simple lines to graph. So here we go. I'm going to graph these little lines. 1, 2, 3, 4, 5. 1, 2, 4, 5. 1, 2, 3, 4, 5. I hope I'm doing okay with time. 2, 3, 4. This is our last example, so hopefully I'll be able to finish it in time. 2x plus 1. Here's our plus 1 y-intercept, and our slope is up 2 over 1 or down 2 over 1. And so we get a line that looks like that. Then we have 2x minus 3, so 1, 2, 3. And again, up 2 over 1 or down 2 over 1. And you get this little guy. Okay? And so what I'm suggesting is that we take this point right there and find the line that is perpendicular to it. Now, why do I want perpendicular? Because we know that the shortest distance between any line and a point on the line is the perpendicular distance. So what we need to do in this problem is we need to figure out, we already know what this point is. This point's easy to tell because it's the y-intercept of this line. So that point is 0, 1. That much I already know. I also know that the slope of a line that is perpendicular to 2x plus 1 is going to be negative 1/2. And because I have the y-intercept and I have the slope, the equation of the line will be very simply y equals negative 1/2 x plus 1. That's the equation of this black line right here. But what I need right now is, if I knew this point, then I could find the distance between these 2 points. And eventually that's what I'm going to do. But how do I get this point right here? How do I know where this line intersects that line? Well, we go back to what we did in the previous example. The equation of this line is y equals 2x minus 3. So I just need to find the intersection of these two. So I'm going to say 2x minus 3 equals negative 1/2 x plus 1. I want to find their point of intersection. So I'm going to add 1/2 to both sides, put this 3 on the other side. And 2x plus 1/2 is actually 5/2 or 2 1/2. But 2 is the same thing as 4/2, so 4/2 and 1/2 is 5/2. The 3's cancel, these cancel, and 1 plus 3 equals 4. If I want to solve for x, I multiply both sides by 2/5, which is the reciprocal, so that I can get that to cancel. And then my x value is 8/5. Okay, once I find my x value, I can go back and find my y value. My y value is going to equal negative 1/2 times x, which we just said was 8/5, plus 1. Okay, so that's going to be negative 8 over 10 plus 1. Is that the one that I wanted to do? It doesn't really matter which one you plug it into, but there we go. So you're going to get negative 8/10 plus 1. And again, it's easier to just call this, 1 is the same thing as 10/10. And so then you're going to go 10 minus 8. And 10 minus 8 is 2/10. But you can reduce 2/10 to 1/5. Lovely fraction. I don't know what I just hate fractions. But so my point of intersection, so this point right here, is going to be x is 8/5. Oops, didn't want to do that. And y is 1/5. So you can see that there's no way I would have ever known that that was exactly 8/5. So I have to do the algebra to get the exact answer. Okay, so we got our point, and so now it's very simple. We're just going to take and find the distance between those 2 points. So I need some space here. My 2 points are 0, 1. That's one of them. That was the first point that we picked on the blue line. And then we used algebra to figure out that the second point is 8/5 and 1/5. And now we're going to find the distance, just like we did in the last example. And we're going to take the difference in the x's, which is 8/5 minus 0 squared plus 1/5 minus 1 squared. And at this point, it's probably going to be helpful to you to have a calculator around, because you're going to get 8/5 minus 0 is just 8/5, but 8/5 squared is 64 20/5. 1/5 minus 1 is negative 4/5, but when you square negative 4/5, you get 16 20/5. And if you add the 64 20/5 with the 16 20/5, you get 80 20/5, and it's the square root of that. So it's going to be basically the square root of 80 divided by 25, which is roughly 1.79 or 1.8 units. So that is how you find the distance between the 2 parallel lines. So now I'm going to ask you to do this guy, and once you've done that, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.